All right, two objectives here. I can write and solve word problems that include multiplication and division. So more multiplication, division, and then we got some rectangular area kind of stuff. I don't think we'll get to this rectangular area today. So there's our fact families. You know, if you ever want to change the division problem to multiplication, or for some reason, if you'd like to change the multiplication to division, you can do that. You know, if you start with 3 times 4, you could make it 4 equals 12 divided by 3, or 3 equals 12 divided by 4, whatever you want. But the two factors, no matter what you do, cannot be your dividend. If you change it into a division problem, they can only be the divisor or the quotient, or either one. And your product is always going to be your dividend. All right, so we're going to use, it says use number sense, which means we can use a fact family here. We have a factor that we don't know yet, times 3 equals 42. 42 is just a little bit beyond our multiplication table. So maybe a division problem would help, where we take the quotient and make it our dividend and change it into division, where we take the factor that we know, which is 3, and just divide it there. Now, again, excuse me, if you can do that in your head, that's fine, but I can't do it, so I'm going to use long division. 42 divided by 3. Okay, well, 3 will go into 4 once. 1 times 3 is 3, so that's how much of the 4 was used. I got 1 left over, so I can drop my 2 there. And 3 will go into 12 exactly 4 times. 4 times 3 is 12, so we don't have anything remaining there, just as we planned. Well, I guess kind of as we expected anyways. And then that means that the missing number would have to be 14, because 42 divided by 3 would be 14. All right, you guys try this one. 9 times something equals 90. Yes, some of you may have this down as 10. Again, if you want to change it to division, you'd have 90. The product has to be the dividend, and then the factor you know has to be the divisor. So yeah, 90 divided by 9 is 10. And again, that's one of those multiplication facts we should know, because 10 times 9 is 90. Yeah, well, here it is, right? So words. We got to be able to translate these word problems into, you know, some kind of multiplication or division problem, and then if it tells us to, we'll evaluate it. It seems like we've seen some of this before, you know, like divided into generally changes the order. I'm trying to think, seems like there's another one, but the rest of these, this is the only one that it changes the order. Remember, multiplication, it doesn't really matter which order it's in because of the commutative property of multiplication, but division, definitely order matters. We usually translate from left to right, but with the exception of this divided into, because divided into will change the order. I guess we'll see some examples. A unique form of multiplication, a triple the number. Okay, so translate and solve. Triple the number 68. I was thinking there'd be a variable there, but no. So triple is 3 times something. Okay. Yeah, it's direct. Now that it's multiplication, it doesn't really matter what order it's in either. Just triple 68, boom. Now that's the translation, meaning on the assignment, that'll be a box that you put in there, okay? Now, if you're struggling to find the multiplication symbol, just use the asterisk button. I think it's Shift 6. I could be wrong on that.
It's Shift 7.
Thank you, Shift 7. Sorry, my typing isn't great, which you've seen. Okay, now, can we actually solve this? Yeah, sure we can. I'm going to write in a different order, though, so I'm going to stack and multiply this. 68 times 3. Okay, so I would do 3 times 8, which would be 24. Of course, that 2 there, I'm just going to carry over into the next place value. And then I would do 3 times 6, which is 18. But adding the 2 extra that we carried over would make that 20. So that would be, I think it's like a box down here. And then you'd put in there the 204. All right, translate and solve. 18 hard candies split among 9 people. You guys try this one. See if you can translate and solve it. Yeah, we're going to take 18. I guess really the question here, we know we're dealing with 18 and 9. A lot of students struggle with the operation that we're using right here. Sometimes they look at split like it's subtraction. Split means we're going to divide the 18 candies with 9 people. So it's 18 divided by 9. Again, that would be a box that you fill in, and 18 divided by 9 is 2. Since this is a word problem, though, where they specifically said what it is, it's 2 candies. We're just putting that on there in case this was a test, because if it is a test and it's a word problem like that, if you don't put candies on that, then you end up getting it minus a point. So the 18 divided by 9 would be good, but then you'd miss this point right here. Well, this one, 6 divided into 42. Now we know it says divided into, so we are expecting division. Here's a mistake though, because we look at most of these translations as direct, and we say, well, it's 6 divided by the 42 right there. And this would read 6 divided by 42, but it's not 6 divided into 42. In order for this to be translated correctly, we'd have to switch those, not just because, as of right now, our dividends should be bigger than our divisors, but because it is just correct, all right? So 42, this is 6 divided into 42. It's like you're taking, well, 42 divided by 6, 7, bam. No labels on this one, but again, this would be a box that you fill in, and then this would be a box that you fill in. So the product is a multiplication problem, so we'll set this up with multiplication of 3. Even though order doesn't matter, we'll still put it in order 3 and 45. So again, this would be our first box, that's the translation, and then we actually need to multiply. So 45 times the 3, and this will be our actual product. So 3 times 5 is going to be 15, but the 1 I'm going to carry over into the tens. And then 3 times 4 is 12, but adding the 1 makes that 13. So our final product actually is 135. Divide 7 into 42. Well, if you could read, that'd be 49, but sometimes I can't do it. Anyways, translate and solve. Well, we're going to divide 7. Well, there's a 7. And we're going to divide it into 49er. Boom. This is our expression. So divide something into, again, that's one of those, it reverses the order. So where this one, usually students would look at this and be like, oh, 7 divided into 49. But division and subtraction can cause some weirdness with the order, and order does matter with these, which is why it's important to understand. It's really asking how many times, in fact, I'll write that out, what the heck? How many times does 7, yep, go into 49, question mark. And that's what this division problem would be. How many times something goes into something else tells you how many times the dividend, or is asking how many times the divisor goes into the dividend. Divisor, dividend, divisor, dividend. All right. There we go. So you sell 32 tickets to a play. The tickets are $94 each. We're going to use rounding to estimate. Oh, rounding. Okay, that's going to make that pretty nice for us. Now, as it is, though, let's go ahead and interpret it as is, and then we'll reinterpret it once we get these values rounded. But it's like having 32 groups or sets of $94. Okay, I'm writing this out so that we know what operation we're going to use. It would have been 32 times 94. Let's go and write that out. 32 times 94, and I know you guys could do that, but it did say to round. Use rounding to estimate the total dollars taken in from the sale of the tickets. This is troublesome because it is not telling us where to round to. But there's only really one place value to round to. If I said round to the ones, then it doesn't change anything, which means it has to be rounding to the, yeah, we got to round to the tens, yep. So let's start with the 30. To the right is a 2, which is less than 5, which means the 3 will stay the same. Tack on a 0, 30. And then 94, the same thing. 9 to the right is less than 5, which is going to make that a 90. Okay, because the 9 is going to stay the same. Now we can multiply these, but it's base 10 multiplication, meaning we got a 30 with a 0 at the end and then a 90 with a 0 at the end. What we can do is take those zeros. I'll take the purple one first and then the green one second, and then I will just do 3 times 9, 3 times 9, which is 27, and we get 2,700. Well, this was dollars, right? Dollars taken in from these tickets, but it's just an estimate, which I don't really care for, because mathematically we should be able to do this and find the exact values, right? So, plus we round it down, which when it comes to money, I'm not really a fan of. Like I like to round up so that I'm not surprised by any costs. But yeah, sorry that's kind of colorful there too. Maybe it's good. Rounded, you'd have $2,700. Boom. So 6 people earn $498 for working at an warehouse, something like that. If they divided this amount up equally, how much will each person receive? So we got to be careful, because I read that first part, 6 people earn $498. In my interpretation, just to start out, I would say all 6 earned $498. There's nothing that tricky usually on the assignment, so we have to be careful on that stuff, okay? But there's only $498 with all 6 people. So we're going to take that $498. Now it says that you're going to, well, I guess they use divided. I thought they said split up, but they're going to divide that amount. So we're going to take it and divide it amongst 6 people. Boom. And once we do this division, it will tell us how much each person gets from the $498, assuming that everyone gets an equal share. So we set this up with long division, 498 divided by 6. Okay, so we look at this one place value at a time. That's not what I wanted. Going from left to right. There we go. So I look at the 4. I see that 6 does not go into 4. So I'm just going to put a small 0 there just to hold that place value. And then I would move this box over so I can make that number bigger. And then we see how many times 6 goes into 49. Now you could make a list of all the multiples, again, just for the sake of time on this specific assignment or lesson. 6 will go into 49 8 times. Now, 8 times 6, 6 times 8, that means that we used up 48 of those $49, and would be left with 9 minus 8 is 1, and then the 4's 0 out as well. Okay, so we have one left over, but now we've got this 8, and we can drop it. Okay, then we see how many times does 6 go into 18? 3 times. 3 times 6 is 18, and when we subtract, there's nothing remaining. But the quotient there, 83, tells us how much every person gets. So the answer actually is technically not 83. You need to remember, with word problems like this, you should always be looking to label it. This is dollars. And if you want to go the distance, you could say dollars per person, but that's more work than I want to do. Here, there are 12 donuts in a box. How many total donuts are there in 14 boxes? Why don't you guys take a minute, try it out, see how you do. All right, but let's go ahead and see how this works. So each box of donuts has 12 donuts, and there's 14 of those boxes. So again, just a quick interpretation here. It's 14 groups or boxes of 12 donuts. Since it's how many groups of something else, it is a multiplication problem. So there's my multiply right there. It doesn't matter which order you put the numbers in. I'm just going to make it 14 times 12, which would both be considered factors. Just using a little vocabulary there. But I'm going to stack and multiply this. So I'd have 14 times my 12. And then we multiply. So let's start with the ones place value with the 2. That'd be 2 times 4, which is 8. And then nothing to carry there, but when I multiply the 2 by 1, still nothing to carry, but we have the 2 at least. Okay, now that's all the ones for my 12. Now I'll multiply the 1, which is really a 10. So I'm going to have a 0 in my ones place value automatically. Then I multiply by the 4. 1 times 4 is 4. And then 1 times 1 is 1. So we can add these together, and this will tell us how many donuts there are, which you guys have already. 168. So again, just a little bit of math there. 8 plus 0 is 8. 2 plus 4 is 6. 1 is just 1. So 168. I need to label that, though, because it is in donuts. Bam. That's it. Now, I use multiplication, which I consider a shortcut right here, or here. You could have just taken 12 and added itself to itself 14 times. You'd still get the same number, and I would be okay with that. All right, rectangles. We've seen this before. Rectangles, the unique thing about rectangles is that the opposite sides are exactly the same length. Now, just so you understand, and I'm giving you a... I feel like this information that I'm about to give you can be weaponized very easily against the math nerds, because they will freak out, just so you know. Okay? A rectangle, usually for a rectangle, one of the sides is longer than the other side. Okay? If you go to a math nerd and they're like, look at that short side right there, that is the length, they might freak out. Now, if you've ever seen a math person freak out, it's actually kind of funny. It's never threatening, which is odd as well, but it's slightly funny, so unfortunately I do it on purpose sometimes. That tells you how the kind of person I am. Anyways, length and width, I really don't care which one you say is which, but if you want to be technical, the longer side is usually called length. Now, we've seen this before. The perimeter is just taking all the side lengths and adding them together. What we see here is that the width, which I'm trying to color code here, on the right, which is the shorter side, because I guess I'm a math nerd, it just matches the opposite sides right there. So the two red sides would be the same width, whatever that number is, and then the length here at the top would match the exact value on the bottom as well. And now you got a rectangle, right? Now there's more conditions to make a rectangle, but I really don't care about those, and we're not concerned about that right now. But since we're in a multiplication and division type application for this lesson, we're now looking at area, which requires usually some multiplication on that. Now, how do you find the area of a rectangle? Well, you just take the length and multiply it by the width. Some people want to say width times length. It doesn't matter. Okay, you're just going to take these two values, whatever they are, and you're just going to multiply those two together, and boom, you get the area. So it's usually shown like this. So if you wanted the area, you take the length, which we usually use lowercase letters for some reason, and then we multiply that by the width. You can show the multiplication if you'd like, but whatever. And that becomes our formula for area. Now, just to relate this to perimeter, perimeter is kind of like the distance around an object. I think about it best with fields, because, I don't know, I like open fields. But if this was a field, you would close it in with a fence, and that would be considered perimeter. But the area would be how much grass you need to fill in, well, the area of whatever the shape is that's being fenced, in this case rectangle, okay? So fencing is perimeter, area is grass. Some students prefer to think of this like a room, though, where you're looking at like baseboards. So this would be how much baseboard you need in length. And then the area would be how much carpet you need in the room. Which is better for you? I don't know. You get to decide. But that's I like to think about it like a field or something. That I forgot to mention on this slide. Units are squared. Okay? Because technically what happens is you're looking at a rectangle, and then you've pretty much made it into really small squares. Squares specifically, which is why we say that it's units squared. But units squared is just showing an exponent of 2 with whatever the units are. So it's an exponent of 2. So for example, you may see something like meters. Meters, if it was area, it would be meters squared. You're welcome to say meters to the power of 2. Some students like to actually show square, abbreviated square meters like this. They're exactly the same thing, okay? So you're welcome to write it both ways, just one way, doesn't matter. But when you put your units on these, make sure that you square them for area. If it's perimeter, no need to square anything, it's just one individual length. So here's kind of what I mean, right? Like if the length here was meters and width was meters, you'd have meters times meters, and that would be simplified as meters squared, square meters, boom. So we want to find the area of this rectangle. Well, I have a length. And yeah, if you're like, you know, that 26 right there is the width, yeah, you can freak out some math nerds somewhere. That's my length, and then we'll call the 13 the width. You're welcome to call it the height if you'd like, doesn't matter. But if I want to find the area, I need to take that length at what I'm going to call 26 yards, and I will multiply it by the width, which is 13 yards. When I get this multiplication complete, I will have the area. This one, once we get the multiplication done, we will square the units, which is yards. But let's get the number down first, and never forget to label our units, especially with word problems like this. So first up, I would look at the 3 in the ones place value and multiply it by 6. Now 3 times 6 is 18. But the 1, 10 right there, I'm going to move over into the next place value, just remembering that I need to add it. Okay, so then the 3, that'd be really 3 times 20, which would be 60, but then I have to add the 1 to make it 70. So we end up with 78. That would be 3 times just 26 right there. Well, that's all of the ones. Now we're in the tens, right? So I'm going to make a 0 in the tens. I would have 1 times 6, which, hey, that's not bad, 6. And then I've also got 1 times 2, which is, so I guess I kind of ran out of space there. What we need to do is add those values together, and that will tell us the total amount of area in this rectangle. Which, by the way, may not be proportional, but whatever. So in the ones place value, 8 plus 0 is 8. 7 plus 6, 7, 8, 9, 10, 11, 12, 13. So again, I'd have 13, but the 1 in the hundreds now I would carry over into the 100s. 1 plus 2 is 3. So 338 is not the answer, though, because we need a label. So make sure that you do, because without it, you may lose credit. So yards, again, is fine as long as it's squared, because we're looking at square pieces that essentially you kind of string together in that rectangle to create the area. And yeah, some students like to show it as 338 square yards. Doesn't matter. It means exactly the same thing. Okay, so this one, it's on a grid. Try it out. So you can find the area of this one, right? And when we do it together, I'll show a couple different ways to do it, okay? Try it out, see how you do. Yeah, that's gonna do it. So you can see, you can count the boxes there. 1, 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Length or width doesn't really matter. 10 by 1, 2, 3, 4, 5, 6. Okay, length and width, which would just be 10 times 6. And as it turns out, we don't need to stack and multiply this. Remember, when we're multiplying by base 10s like this, we can just tack that 0 onto the end, and then it really just becomes 1 times 6, which is 6. You're still welcome to stack and multiply, by the way, but that'd be 6, making the final answer 60. This one, it didn't give us the units, right? So you could say units squared. I don't know. I think that's a little overkill, because we don't know what type of units those are. Are they square centimeters, square inches? We don't know. But I do like that this diagram is showing, see all the squares inside, right? Those are what we're talking about when we're talking about squaring the units. You're making little squares on the inside of whatever the shape is. This one just happens to be a rectangle. I like this one right here. So we want to find the height there. You can call it width or whatever. But find the height if the area is 286 square feet. See if you can do it. Try it out, and then we'll go over it. All right, so just go back on this one. We have length here, 23 feet, and it's got to be multiplied by something, right? Some kind of length, width, whatever you want to call it, height, and then that would equal, it already gave us that area up here at 286. Now, the 23 is a factor, the 286 is a product. If we wanted to switch this to a division problem, we would take the product as the dividend, 286, and then we could switch the operation to division by just dividing it by the divisor, 23. So, as long division, this would show 286 divided by 23. And we actually don't need that many multiples of 23, right? We got 23, it's its own first multiple. Then we add another 23 to get 46, and that, I think that's as far as we need. So 23 goes into 20, again, it wouldn't go into 2, but 28, so you could put a 0 there. But 28, it will go into once. 1 times 23, boom, 23, and you can use the chart there. But that'd leave you with 5 there, so drop to 6. 23 doesn't go into 56 evenly, so yeah, we're going to expect some kind of remainder here. It's only going to go into it twice. So 2 times 23 is 46, which again, you can refer back to the chart there. So that's 6 minus 6 is 0, 5 minus 4 is 1. That's our remainder there. So 12 with the remainder 10. 12 remainder 10. I guess this would be in feet right there. Now, again, I did not expect this remainder, but yeah, I wouldn't put it past them to put something like that on the assignment. So problems like this one, we did a perimeter problem with this, and if we're not sure, the 3 is that little piece right there. It's not very proportional, not that we care. But here's what we got to do with this one. There's actually 3 different ways to do it. Okay, so let's try that method. We're gonna find the big rectangle and then subtract that little piece, right? So we got 7 inches at the top and then 3 right there, which would make up the whole bottom part of this shape. So that would be a 7 plus 3, which is 10, and that's in inches right there. Okay, and then call that, I guess, the width, and then the height. There's 8 inches there, so this part would be 8 inches. And then this part here also, sorry my lines aren't very straight, but that'd be 8 inches too. So if we add those two together, then we get the full left side, which is 16. 16 inches. Okay, so we have this. Let's go ahead and let's make our shape here. So again, we're going to look at this as a big rectangle, which I guess I'm putting in green now. But I have the length and width. I've got a 16 by 10 rectangle. So we can find the area. Again, we're looking at it as a whole rectangle. So we're going to make this a 16 times 10. Which again, for me, I would just say, you know what, just take the 0 from the 10, tack it on, and then 16 times 1 is, well, 16. So the whole rectangle, including the part that's not actually part of the original shape, would be 160 square inches. But then we have this other rectangle here. Let's make this one orange. In fact, there we go. This part right here, the orange part is not part of the original shape, so we have to take that off. We're going to cut it off, right? And by cut off, I mean we're going to subtract it. So we're going to subtract that shape, which is, looks like it's an 8 by 3 inch rectangle. So the area of that rectangle would be 8 times 3, which is 24 square inches. So we're going to subtract 24 here at the top. And what we get from this subtraction will be the area of the original shape. So we'll make this 10 minus 4 by borrowing from the 6. 10 minus 4 is 6. 5 then minus 2 would be 3, and then drop the 1. Boom, 136. Again, you can label it in inches squared, but square inches, I'm okay with it. I like it. All right, 1.8. There's our objectives again. I can write and solve word problems that include multiplication and division, and I can solve applications of rectangular area just like we just barely did.